Here we're going to go and do the advanced notes for advanced stoichiometry of the gas laws. All we're going to do is stoichiometry and gas laws and put them together. So let's look at a problem. Determine the volume of carbon dioxide gas formed if 87.45 grams of ethane, which is C2H6, reacts with excess oxygen at 35.8 degrees Celsius and 10.8 kilopascals. Now, if we start with a mass, we do stoichiometry first. So we're given a mass right here, 87.45 grams. We know that mass. So we're going to do stoichiometry first. So we start with a reaction. C2H6 plus O2 yields CO2 plus H2O. That's a combustion reaction. Balance it up. Put a 2 because we're going to have to drive the reaction. Get 4 and a 6 and a 7. Everything balances out. Now, start with the given information. The 87.45 grams. Now, in order to go from grams to moles, we need formula mass. 1 mole of C2H6 is 30 grams of C2H6. All right. Using our equalities here. 2 moles of C2H6 is 4 moles of CO2. 4 moles of CO2 over 2 moles of C2H6. And 22.4 molar volume of CO2 is 1 mole. We multiply that through, cross everything out, we get 130.6 liters of CO2. Now, we have 2 sets of conditions. So we're going to use the combined gas law. All right, so that means V1 is 130.6 liters. This is at STP. So therefore, P1 in kilopascals is 101.3, T1 is 273. And there's our set of values. So V2 is unknown, P2 is 110.8 kilopascals, and T2 is 308.8 Kelvin. All right, we're going to solve for V2, put our value, it's going to equal, put our values in. So we have P1, P1, V1, T2 over T1, P and T2, P2 right there, sorry. And we multiply through, cross everything out, we get an answer of 130.1. That's my answer. All right, now, let's try another one. Determine the mass of potassium chlorate needed to decompose into 16.85 liters of oxygen at 91.5 degrees Celsius and 1.099 atmospheres. All right, so if we're given volume, we start with the combined gas law. So there's a combined gas law. That's my distinction. So my first set of conditions, P1 is 1.099 atmospheres, V1 is 16.85 liters, T1 364.7. That's just 91.7 plus 273. And my other set of conditions are at STP. Put our values in, cross them out. We get a V1 of 13.86 liters. Now we do stoichiometry at STP. So KClO3 is going to yield KCl plus O2 decomposition, balancing it out. All right, so we start with our first factor. Then we convert from liters to moles because it's molar relationship. We're now at STP. We then go from KClO3 to O2. So the fraction is 2 moles KClO3 over 3 moles of O2. And then we do formula mass, multiply through, and that's my answer. Alrighty, now this one I want you to copy down. We'll do this one in class. We'll figure out which way to go. And this one we'll also copy down. We'll do this in class. This one you'll really like because it's very simple. That's it. I know it was real quick, but that shouldn't be too bad. Take care. Be good.